will discuss the multiplexer. The multiplexer is with a multiple input but only one output. That is the simplest definition of a multiplexer. Here we will show that with a block diagram n is to 1 multiplexer. In that we have shown that there are inputs to the multiplexer are D0, D1 up to Dn minus 1. Therefore, total number of inputs are n here. And output will be one of them, that means from D0, D1 up to Dn minus 1. One of the input will become the output. And which of the input will become the output, it will be decided by the another type of input. We call it a control input or a select line, and that is equal to, we have shown here, it is 1 to the up to the m, and there is a relationship between that. That means total number of inputs here will be the 2 to the power of m. That means here number of data inputs will be 2 to the power of n. That means if there are two control inputs are there, therefore data inputs, maximum data inputs may be 4 to 2 square. That maximum data input may be 4. In that way we call it a 4:1 multiplexer or 4:1 multiplexer. Now let us take an example of a very simplest example of a 2:1 multiplexer, 2:1 multiplexer, which will implement by a basic gates. That is the basic we have. This is the only, because 2:1 multiplexer, there will be only one control, and that is we have denoted by A, and another, and you can see the AND gate. I can name it is a 1, is a 2, and one of the input to the AND gate is a D0, and because only one control is there, 2 to the power of 1 is 2. Therefore, 2 input will be there. Therefore, these are the D0 and D1 are the inputs, and this is the circuit for 2:1 multiplexer. And you can see to the one of the OR gate, one input is the D0, another is the A complement of A, and the second AND gate, it is the D1 and A, and in this case we'll show that what will be the output in this case. If A equal to 0, therefore complement of A will be equal to 1, and in that case whatever the value of D0, that will become the output. And because A equal to 0, therefore this output of this equal to 0, and here output will be equal to D0, because when A equal to 0, that complement of A equal to 1, and the output of that gate always it will be whatever the value of D0, this will be the output. As a result, output of the OR gate also, it will be D0. And when A equal to 1 and complement of A will be equal to 0, and as a result the output of the gate number AND gate will become 0. And here in the gate number 2, you can see A is equal to 1 and the output will be D1 next. It will become D1. And as a result, the output Y will be equal to D1. Therefore, we can come to the truth table. You can see the truth table also. You can see this is the A, this is the Y. That means completely the Y, the output depends on what the control select line takes its value. When A equal to 0, the output becomes D0, and when A equal to 1, and output becomes D1. And from this is and then another important thing in this case, that if we want to write the logic equation for 2:1 multiplexer and this circuit, and Y equal to, you can see this is the A bar into D0 plus A into D1, and summation of this by the OR gate, summation of this. Therefore, these basic gates we have written in these expressions, and that is the logical expression that is required. So many simplification we'll discuss it later on.